Hello students, what I'd like to do is to walk us through a couple of examples of specific decomposition and composition or synthesis. I'm going to work through a couple examples in this packet for all of us. This is from a fellow AP Chem teacher. Now, I definitely added in the previous video more synthesis and specified what I want to point out as far as decomposition. But this isn't a bad summary from this fellow teacher of the way he presents to his students decomposition, single replacement, double replacement, and combustion. He made a note, and I'll talk about this to come, that if ammonium hydroxide is a product, it readily decomposes to give us ammonia and water, whereas, as I said in the previous video, carbonic acid readily breaks up into carbon dioxide and water. And something we definitely want to make a note of is being careful of phase symbols whenever possible, So, if we can go ahead and entertain a few on this first sheet here. Now, I want to point out that these ick and us, if we ever see that with the Latin element original name, this of course is iron, but ferric and ferrous. Ferric refers to the greater oxidation state on the metal ion and the us to the lower, relying upon us to know, for example, that iron readily forms a +3 and a +2, this being ferric and this being ferrous. Copper most stably shows us +2, sometimes can be +1. This is cupric and this is cuprous. But that really is an old-fashioned system of naming. This will be referred to modernly as iron 3 and iron 2, and then of course this as copper 2 and copper 1. So if you see this throughout the packet, please don't worry about these. It would read modernly solid iron 3 chlorate, solid copper 2 carbonate. All right, so I'd like to just refer to a couple of these to just walk us through some samples. Solid magnesium carbonate is heated. And we're just being asked for a balanced chemical equation, which would mean an overall reaction, including states of matter, meaning phase symbols. Solid magnesium carbonate. Now, because we're being told it's heated, we could put that open triangle above the arrow, but not necessarily required. Metal carbonates give us metal oxides and carbon dioxide. Now we know carbon dioxide will exist as a gas. This is an ionic compound. We don't even have to ask if it's soluble or not. We don't have any water available, so this will be assigned a solid. Let's check the formula. +2 - 2, we're good. And we are balanced as written. This would be the final result. So let's take a look here. Solid calcium oxide is mixed with water. Now, whenever we are reacting with water, we have to be careful for several reasons. Our awareness has to be heightened. We have to be on guard because this could be one of our special composition. A non-metal oxide plus water gives an oxyacid. A metal oxide plus water gives a metal hydroxide, and that's what we're getting here. So this is one of our special composition. We will get a metal hydroxide. +2 - 1. Our alkali and alkaline earth hydroxides, there's varying solubilities. Hydroxides are kind of stubborn at creating soluble, are normally kind of slightly soluble. However, I think with confidence we can go ahead and call this aqueous, even though it's in that slightly soluble realm. Now, Along with water, it could be single replacement. If we're adding a metal, we have to check. If it's a very active metal, then we're going to get a metal hydroxide and hydrogen. If it's less reactive, a metal oxide and hydrogen. But this, of course, is a special composition. Let's just be sure we're balanced. 1 calcium, 2 oxygen, 2 oxygen, 2 hydrogen, 2 hydrogen. Great. This will be another example of a metal oxide plus water. Here's one of our combustion. Methanol, hydrocarbon, is ignited. We would assume that is giving the required spark. We would assume it's in the presence of air, and so definitely oxygen gas, methanol gas, and we will create CO2 gas. And because it's such an exothermic reaction, we would anticipate water would be in the gaseous state also. Let's check if we're balanced. 1 carbon, 4 hydrogen. Let's put a 2 here. Then we have 3 oxygen and 4. So let's try a 2 there, a 2. That then gives us 8 total hydrogen. So let's make this a 4. That would give us 4 and 4, 8 oxygen, a 2, so we need a 3. And then we're balanced. Solid sodium chlorate. +1 -1. When we decompose a metal chlorate, we get a metal chloride and oxygen gas. +1 -1. That is an ionic compound with a very, very high melting point. So even though we're heating, it's not going to liquefy, even with a Bunsen burner. And we're going to need a 2, a 2, a 3, and this, of course, will be gas. All right. Let's see. We have another chlorate. Dinitrogen pentaoxide gas is bubbled through water. Well, this would be a non-metal oxide plus water. Again, with water, our awareness has to be heightened. So this is one of our special type of composition where we are going to create the oxyacid. Non-metals love oxygen, so that nitrogen is going to steal the oxygen. Now, we should be forming polyatomic ion that we recognize. If we directly add the oxygen and the charge of that oxygen. What on earth is N2O6? Not a polyatomic ion that we're familiar with. But this can be reduced, can't it? This can be reduced to NO3 -1. Hydrogen partnered with that, +1. Then, to balance, let's see. We have 2 nitrogens. Let's try a 2 here. We would have 2 hydrogens. We're good. 6 oxygen. Look at that. And I expect that some of that water will be left over, and we know, of course, that that is soluble. Well, let's see. We haven't done we did a carbonate. This would just be another example of a carbonate. Let's see. Solid strontium hydroxide. And strontium hydroxide, we would decompose this to get the metal oxide and water. +2 -2. And then we're balanced as written. Now, this will be a solid. We would anticipate solid. And then, that's hard. I'd safely say liquid. Even if we're heating, we're going to heat to decompose. So I'd say water will very readily be found in the liquid state. Let's see. Aluminum metal, not diatomic, is heated in a fluorine environment. Fluorine and chlorine are diatomic, and they are gaseous in the halogens. Bromine, diatomic but liquid. Iodine, diatomic but solid. element plus element. Plus 3 minus 1, AlF3, ionic compound, solid, a 2, and a 3 to balance. Let's see if there's any other. So this would be might seem like a unique one, but this is a good time to remind us that hydrogen peroxide. Now, peroxide is a polyatomic ion where each oxygen is showing a -1 charge. How strange. This naturally decomposes, but with a catalyst can be sped up to give us water and oxygen gas. So we did this to generate oxygen in honors chemistry, but we use hydrogen peroxide to wash and disinfect cuts. Let's make sure we're balanced. We would need a 2, and we are good. Let me just see. I think these, have definitely addressed the composition and the decomposition. But some examples, dealing especially with single replacement, double replacement. So, whenever we are adding a compound to water, an element to water, or an element to a compound, it absolutely will satisfy single replacement. We have checked the activity series. Our alkali metals absolutely will react with water. In fact, they are going to create the metal hydroxide, +1 -1, and liberate hydrogen gas. Now, if they were less reactive, but still reactive enough to take the place of hydrogen, for example, believe it or not, iron 2 and iron 3, most probably iron 3, solid, will react with water. However, that is going to create the metal oxides and liberate hydrogen gas. I want to make sure that we're, of course, balanced, and we need a 2, and a 2. And then we're good. We're here. We are going to need a 2, a 3, and a 3 to be balanced. All right, let's see. Phosphoric acid. Now, solution, AQ, is poured into a beaker containing calcium metal and makes a precipitate. Calcium, an alkaline earth, is definitely reactive enough to take the place of hydrogen. Remember, cation replaces cation, just like we saw here. And calcium phosphate is a precipitate. Now, the reason why, this is hard, because remember, a precipitate is a solid form from the mixture of two or more solutions. So this is technically not creating a precipitate. It's just creating a new solid from what appeared to be a different solid. And we should also be getting production of gas. So, to balance, I believe we need a 2, a 3, and a 3. Yes. And here, this is better as far as producing a precipitant. So, lead 2 nitrate, chromium 3 iodide solution. Now remember, all nitrate compounds are soluble. Now, unless otherwise told, unless it's an oxidation reduction, then whatever charge the metal ion is showing here should be the charge here. So +3, +3. So it'll be Cri3 and then CrNO3, and all nitrate compounds are soluble. However, remember, halide compounds lead 2, mercury, silver, mercury 1, and silver compounds are insoluble. So this will create PbI2. That is that stereotypical big bird yellow solid. And we'll need a 3, a 2, a 2, and a 3. That gives a good example. I will post other examples for you to try, take a look at. Please feel free to send any questions my way or, of course, ask in class.